Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about the chapter structure of atom. In this session we are going to see a practice sheet related to this chapter. That is practice sheet 1, which includes completely single correct answer type questions that may contain like conceptual understanding questions even and single correct answer type questions. Okay, let us start the practice sheet. First, let us see conceptual understanding questions. See the first one. The first atomic theory was proposed by. Who proposed the atomic theory for the first time? Yes, he was John Dalton. John Dalton proposed the first atomic theory. Okay, the concept of atom was proposed by him. Of course, in our Indian philosopher, also one of the philosophers, namely Maharshi Kannad, also has given a proposal about the atom. In his scripts, he given some statements like every padartha is made up of anus. These anus are the composite of paramanus. This was given by Maharshi Kannada before 600 BC. In around 400 BC, John Dalton has given this proposal that the atomic theory, which was proposed by John Dalton. He told that atoms are the smallest particles of every matter. Okay, he was John Dalton. But the term atom was for the first time used by Democritus. But the theory of atom for the first time is given by John Dalton. Next question. The number of waves passing through a point per second is called. Yes, number of waves passing through a point per second, number of cycles or number of rotations, number of oscillations per second. These all will come under definitions of frequency. The number of waves passing through a point per second is called frequency of that radiation or frequency of that wave. Okay, it is frequency. Next question. The wavelength for a given type of electromagnetic radiation is. So in the options they have given about frequency. So the relation between the wavelength and frequency they're asking here. How they are both related. If the wavelength of a radiation is much greater, then the number of waves passing through a point per second will be less. So the frequency of that radiation will be less when if the wavelength is greater. If the wavelength of a wave is very smaller, suppose a wave is having wavelength this much of lengthy wavelength, then if a point is kept in the path of this wave, the number of waves passing through this point per second will be less. If you take another wave with a wave very less wavelength like this, if a point is kept in the path of this wave, then number of waves passing through a point per second will be greater. So from these two examples, what can we understand? If the wavelength is greater, frequency is less. Vice versa. So how these two are related now we can say? Wavelength is inversely proportional to frequency. Isn't it? Yes. Wavelength is inversely proportional to frequency for a given type of electromagnetic radiation. Where is it? In the second option. If you observe fourth option, they have given instead of frequency they mentioned here wave number. Let us see how these two are related, wavelength and wave number. We know the reciprocal of wavelength is defined as wave number. So reciprocal means inversely proportional. But here they mentioned directly proportional. So wavelength is inversely proportional to wave number and even it is inversely proportional to frequency also. So second option is correct here. Next, as frequency increases, energy of the electromagnetic radiation. How these two are related, frequency and energy. According to Max Planck's quantum theory of radiation, energy emitted by the particles like electrons, energy emitted by the waves is not being continuous. It is being discontinuous in the form of small packets. each packet of energy is called quanta. The energy associated with this quanta or packet of energy is directly proportional to frequency of that radiation. So we can say now energy is directly proportional to frequency. So if frequency increases, energy of that radiation also increases. So where is the option now? As frequency increases, energy of the electromagnetic radiation increases because energy is directly proportional to frequency of the radiation. Okay, next, quantum theory of radiation was proposed by who proposed quantum theory? Just in the above question we have discussed. Quantum theory of radiation was proposed by Max Planck. What it is stating? Quantum theory states that energy emitted by the particles or waves is not being continuous, it is being discontinuous. This each packet of energy is called quanta. The energy of each packet or quanta is directly proportional to frequency of the emitted radiation. Okay, this was proposed by Max Planck. This quantum theory was proposed by him, Max Planck. Next question. Which of the following relations is correct? See here, some relations are given between the characteristics of electromagnetic radiations. Observe them. Which of those are correct? Identify here. See the first one. Nu is equal to C by lambda. We know wavelength and frequency, nu and lambda are inversely proportional one to another. So we can write it as nu is equal to, or nu is directly proportional to 1 by lambda, or nu is inversely proportional to lambda. So to remove the proportionality here, a constant c is taken. Now it has become nu is equal to c by lambda, where c is the velocity of light, which is equal to velocity of light, which is a constant. So this relation is correct. See the next one. E is equal to h nu. Yes, according to Planck's quantum theory of radiation, E is directly proportional to frequency. Then to remove the proportionality, here also a constant h is taken, which is called as Planck's constant. What is the value of this Planck's constant? 6.625 into 10 to the power of minus 34 joule second. So this relation is also correct between the energy and frequency. Next relation, nu bar, which is called wave number. Wave number is equal to 1 by lambda. It is also correct because we know wavelength is the reciprocal of wave number, or wave number is reciprocal of wavelength. Number of wavelengths per unit centimeter is called wave number. So it is reciprocal of wavelength. This statement or relation is also correct. Now what will be the correct option for this question? All of these three relations are correct. Okay. Next, single correct answer type questions. See the first question here. The value of Max Planck's constant is, just now we told the Planck's constant H value is 6.625 into 10 to the power of minus 34 joule second. So the value is given here. It is equal to joule second. 6.625 into 10 to the power of minus 34 joule second. And it also can be mentioned in other units as 6.625 into 10 to the power of minus 27 erg second. So it is mentioned in the first option, erg second. Now in the question, if you observe once again, Planck's constant in Celsius units, out of these two, where the Celsius units are used here, erg second. Now the value of Planck's constant in Celsius units is 6.625 into 10 to the power of minus 27. This is the value in units erg second. Okay, this is correct. Next, as the distance from the nucleus increases, energy of the electron decreases, energy of electron increases. does not affect, depends on the nature of the atom. Actually, as the distance from the nucleus to the out electron increases, what happens? Energy of the electron increases. The electrons which are nearest to the nucleus are in the first orbit are having the lowest energy. As the distance from the electrons and nucleus increases, their energy will be increased. So if you consider this as E1, the electron in the first orbit, suppose the electron in the fourth orbit like this with energy E2. Now it will be E2 will be always greater than E1. That means energy of the electron in the higher orbit will be always greater than that of the electron in the lower orbit. So as the distance from the nucleus increases, energy of the electrons increases. Where is it? In the second option. Okay. Next, as the orbit number increases, the energy difference between the two adjacent orbits. Yes, it is also similar like eighth question, but there is difference between these two. Observe carefully. As the orbit number increases, the energy difference between the adjacent orbits. So as here in this question, what it asked, as the distance between the nucleus and the electron increases, energy of the electron increases. But here in the next ninth question, it is asked as the distance or as the orbit number increasing, difference between the energies of two adjacent orbits decreases. Suppose here this is the first orbit, this is second. The difference between these two orbits energies will be greater when compared to the difference between the energy difference between these two second and third orbits. That will be greater than the energy difference between the fourth and third orbits. So energy of the orbits will be increasing gradually, but the energy difference between the two adjacent orbits decreases as we move away from the nucleus. Got this point? Good. Next, next question. The wavelength of a blue light is 4800 angstroms. The frequency of this light is. So what is given here? Wavelength lambda is given and asking to find out frequency. What relation we have between these two? Let us see first the solution. So this is the solution for this question. See, we have nu is equal to c by lambda, where nu is the frequency, c is velocity of light, lambda is the wavelength. Already lambda value is given as 4800 angstroms. Okay, if we convert this into meters into 10 to the power of minus 10, we have to multiply. Then the units will be converted into meters. Angstroms can be converted into meters by multiplying with 10 to the power of minus 10, because 1 angstrom is equal to 10 to the power of minus 10 centimeters. 1 angstrom is equal to 10 to the power of minus 10 meters. So if you multiply with 10 to the power of minus 10 meters, we can convert this wavelength into meters now. So wavelength is given. C is a constant whose value is a constant, which is equal to 3 into 10 to the power of 8 meters per second. Now C value is known, lambda value is given, asking to find out frequency. If we substitute the values of these two, velocity of light and wavelength, we get the final frequency value as 6.25 into 10 to the power of 14 second inverse. Where is it? Yes, here. So this is the correct answer. Okay. Next question. Calculate the energy associated with a photon of light whose frequency is 3 into 10 to the power of 15 second inverse. So what is given in the question if you observe, and what is to be found? If you understand these two, we can find out the answer very easily. See here, they have given the frequency. Calculate the energy, means they are asking to calculate energy of a photon with a frequency 3 into 10 to the power of 15 second inverse. Frequency is given and asking to calculate energy. What relation between these two we have? We know energy is equal to h nu. E is equal to h nu. We have that formula. Let us see the solution so that we can understand. So frequency, sorry, it is a frequency, not a wavelength. Frequency value is given as 3 into 10 to the power of 15 second inverse. And we have a relation between these two, energy and frequency, from the Planck's equation, that is equal to E is equal to h nu. And here h is a Planck's constant. H is called Planck's constant, whose value is equal to 3 into 6.625 into 10 to the power of minus 34 joule second. Now H, Planck's constant value, is known. Frequency is given. Now we can calculate energy by substituting these values. What do we get? Finally, by substituting these values, we get it as 1.98 into 10 to the power of minus 18 joules. Where is the answer? Here, in the second option. Did you understand? They have given frequency and asked to calculate energy. Then, between these two, there will be certain relation between the given quantity and the quantity which is to be found. That is E and nu. What relation we have here? E is equal to h nu. H is being a constant whose value is known already. Now, if we substitute these values, we get energy. Got it? Next question. The ratio of energy of photon of 2000 angstroms wavelength to that of a photon of 4000 angstroms wavelength. So here the wavelengths of two different photons are given and they asked to calculate the ratio of their energies. It can be done by calculating their energies because here wavelength is given. Between the wavelength and energy there is a relation, that is E is equal to h nu or h into c by lambda, because nu is equal to c by lambda. Now we can say E energy is equal to hc by lambda. By substituting the values of hc and lambda, we can calculate the energy of each photon and we can calculate the ratio. That's one. Otherwise, directly also we can do this problem. That is by taking the relation between the energy and lambda. So from this we can say h is a constant, c is also a constant. Okay, by removing these two, what we get? Energy is directly proportional to 1 by lambda. By taking the relation, we can find out directly ratio of energies. See the solution. So lambda values are given. Lambda or wavelength of first rate photon is this. Wavelength of second photon, both are given. Now we have relation as we have written here. E is equal to hc by lambda. From that we can write E is directly proportional to 1 by lambda, or E1 by E2 is equal to delta 2 by delta 1. So if we substitute these delta values, we get the ratio of their energies as 2 is to 1. Got it? So in this way, the ratio of energies found as 2 is to 1. Where is it? In the fourth option. Got it? So need not to calculate the energies of each photon, and then we can need not to calculate ratio. Directly we can take the ratio of their energies in terms of wavelengths. So it becomes easy here. Okay. Next, calculate the energy associated with the photon of light whose frequency is this. So frequency is given and asked to calculate energy. Already have done some problems like this. What is the relation? E is equal to h nu. So if you substitute the value of frequency, we can find the answer. See the solution. Lamp again. Oh, I think we have done once this problem. Okay, no problem. Frequency is given. Asked to calculate energy. Substitute the values. We get it as 1.98 into 10 to the power of minus 18 joules. Where is it? The third option. Next, the electronic configuration of phosphorus is. To know the electronic configuration, first of all, we should know the atomic number of the element. So if you know the atomic number, So we can calculate, we can come to know the number of electrons present in that atom. If no number of electrons, then we can write electronic configuration. So let us come back to the atomic number of phosphorus. What is the atomic number of phosphorus? It is 15. It means there will be 15 electrons in the phosphorus. So for 15 electrons, we have to write the configuration. How can we write it? So first we start with the first energy level, 1s2, 2s2, next 2p6, then 3s2. How many electrons finished? 2 plus 2, 4 plus 6, 10, 10 plus 2, 12. Totally 15 electrons are there. 3 more electrons are there. So those will be entered into 3p subshell. As we know, 3p subshell contains the 3 orbitals. So according to Hund's rule, each degenerate orbital will be occupied by single electron. That is why we write it as 3px1, 3py1, 3pz1. So in this configuration, this can be written as neon because this configuration represents neonic configuration. So the electronic configurations of the elements also can be represented by using the symbols of nearest noble gas symbols also. Okay, here in the place of this we can mention neon, which is mentioned in the square brackets. Okay, neon 3s2, 3px1, 3py1, 3pz1 is the electronic configuration of phosphorus. Where is it mentioned? See the second option. Okay, these are two configuration. This is correct and this is also correct. Sometimes the same also mentioned can be mentioned like this: 1s2, 2s2, 2p6, 3s2, and next 3p3. Instead of expanding this p subshell into orbitals, directly they may write 3p3 also. This configuration also representing phosphorus only. Okay, whatever they give in these options, out of these three, all will be correct answers only. Okay, next question. The atomic numbers of elements X, Y and Z are 19, 21 and 25 respectively. The number of electrons present in the M shell of these elements follow the order. So they're asking the number of electrons in the M shell of these atoms. So if you write the electronic configurations, then we can identify the number of M electrons in these three elements. Then you can say the answer. So the solution, we say element X with configuration atomic number 19. What do we get configuration? It's like this. We can say it is potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now they're asking the number of M electrons or the number of electrons present in the M shell. M shell means KLM, that is third shell. See here for this element X in third shell, totally how many electrons are there? Totally there are 8 electrons. So for element X there are 8 electrons. Next, if you observe for the element Y, if you write the configuration for 21 atomic number, we get configuration as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now, how many electrons are there in the M shell? That means the third shell, this 3s subshell, 3p, 3d. These three will come under third energy level or M shell only. Now, these all electrons will come under M shell electrons only. How many are there totally? 9 electrons. Okay. Next element Z. Atomic number is 25. If you write the configuration, we get it as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Then if you see how many electrons are there in the third shell, that means M shell. See how many are there? 2, 6, 5. Totally there are 13 electrons. Now which element is having greater number of M electrons? Z. Next Y and then X. Okay, where is this correct answer now mentioned? In third option. Okay, To find out the number of electrons in an orbit or shell or subshell, better to write the electronic configuration of the element first, so that we can understand these all points very easily. Got it? Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates on recorded videos.